And as that refrigerant changes state, it absorbs the heat in the evaporator, and once again it becomes a low pressure gas and then returns to the suction side of the compressor. And as the suction pressure increases, the compressor will start, and once again the system starts again where the refrigerant vapor is compressed and is discharged on the left hand side of the compressor. Okay, the condensing process. This is a condensing unit, so it's got a compressor, liquid receiver, and a condenser. The evaporator is probably in a factory, but you can't see that side of it. So here we have the compressor, 1. This is the discharge side of the compressor, 2. And this is the discharge line where our high pressure superheated vapor goes towards the condenser. Now, we want to lose the superheat before we can condense, and that's why the liquid or the discharge line from the compressor is uninsulated, because it's not useful to have that superheat in the condenser. The temperature of the vapor or the gas leaving the compressor can typically be 60 to 120 degrees. So that's a typical condensing unit. The liquid refrigerant, the condensed liquid refrigerant, is coming out of the bottom of the condenser, and then it's going into this liquid receiver, which is a small vessel. This is our liquid line or condensate line, which will be going off to an evaporator somewhere in a factory or in an air handling unit somewhere. So you've got your superheated vapor, and that's entering the condenser, with your cool air being pulled across the tubes. The superheated vapor is cooled. As it begins to cool, it begins to condense into a liquid, and we have our liquid leaving the condenser. Only when the condensation process finishes, the refrigerant temperature starts to fall once more. And you don't see 100% liquid leave the condenser. There'll probably be a small amount of vapor in there. So here we have a horizontal flatbed condenser. At the end of the unit, we have our header, which would be connected to the discharge side of the compressor. So our high pressure superheated vapor enters the condenser. Now the vapor travels the length of the condenser, and then the pipework is returned. So it's that sort of direction. The condenser fans pull the ambient air through the condenser coils, and then the heat is rejected out through the outlet of the condenser fan. The liquid, which is the blue line at the bottom, your condensed liquid refrigerant, leaves the header at the bottom here. So that's simple horizontal condenser. Okay, we're going to just go through types of condensers. So this is what we've just seen. This is the horizontal, double row horizontal. As I said, your superheated refrigerant comes in here. This is the direction of airflow. Your heat transfer takes place in these coils, and your condensed liquid refrigerant leaves the condenser on the other side. Now, very important to understand this is that to clean the condenser and to make sure that we can we get good heat transfer, we need to clean this condenser in the opposite direction of airflow. So essentially, we need to clean this way. Now, some manufacturers have got fan plates that can be removed or on hinges, and sometimes you can get a lance through the fan. So, very important to remember, always clean in the counterflow direction, otherwise you'll be pushing dirt and debris further into the coil. Here we have a double row horizontal condenser, and this system is 2 condensers operating in parallel. There's your transducer there, your pressure transducer, which will be sending a signal back to the controller. This is a vertical condenser, but essentially it's a flatbed condenser and it's vertically mounted. In this case, the airflow is this way, away from the building. This is a V-type condenser, double row, so 2 sets of fans run along the length of the unit. The superheated refrigerant gas enters the top of the condenser. We have our ambient air being pulled through the sides of the condenser, and our condensed refrigerant leaves the bottom of the condenser. And notice again the direction of airflow. So if we need to clean this, we need to do it from the top outwards. We need to clean that way. Okay. Now, this is a large double V condenser. You can see a chap standing there. So let's say he's 2 meters. So you can see that's 6. It may be 7 or 8 meters tall. And this is an ammonia system, so it's very expensive because the condenser is constructed from stainless steel tubing rather than copper. And what's different about this unit is this is the condenser fan, the black area here, and sandwiched between that we have attenuation on the, we call this the suction side of the fan and the discharge side of the fan. Now, this area was surrounded by trees and shrubs. It's in a city centre, so it's going to get dirty, and the direction of airflow is like this. Now, as this condenser gets dirty, the performance is going to suffer, and the only way that's you're going to be able to clean this is by switching off the system. Now, we don't have a duty standby condenser, it's just a duty, but we're going to need to put scaffolding platform around the unit, and the fans and the attenuation are going to need to be removed. So if you're involved in servicing equipment or buying new equipment, very important, how are you going to clean the coils? Some manufacturers put a service panel down the side here, and other manufacturers have put in a hinge plate on the fans.